Okay, so I promise to show you kind of the advantage of, well, I didn't do one of the problems I should have done. Let me try to do one of those other problems with the multiple connections first. Give me a second. I think it's there. I can't remember. Nope, it wasn't there. That is 4, so it is 3. Yeah, here's 3. So let me do one of the problems with 2 rings on it first. What I'm going to do it with the normal. Let's see. There's 2 of them. Which one seems more intriguing? I don't know. Really doesn't. I don't think it matters. I don't know. This one has 2 problems associated. Well, both of them have 2 problems associated with them. Let's just do that one. Just at it. I mean, the procedure is exactly the same. So, uh, all right. So let me do the copy. And I will need to change the mode. Go and copy this and drop it over here. So there's the thing. Obviously, he wants to know the tension in all these cables. Don't ask me why he would do the lamp this way, but there is probably reasons you might want to. Don't know what those are. It doesn't matter. Which one do we do? Determine the tensions for each of the, okay, 20 kilograms. Let's just do that one. Okay, so this thing is 20 kilograms. So, okay, this is a 20 kilogram lamp, which means the weight is equal to mg, or this. And I do not, sorry, we'll have to wait a second. I don't have that up yet. So let's see. The, oh, there it is. Okay. 9.81. I should know that. Oh, okay. 196.2. Okay, so that's going to be the weight. So obviously that's going to be the tension in this thing. So this thing's going to have to be 196.2. And this one's going to have to be 196.2 as well. However, what I'm going to do is something a little bit strange here. So I'm going to go ahead and work the problem this way. When we get to chapter, when 3D versions of these things, you'll see in the book, and I'll show you where it actually breaks into these components in these base vectors. So if you don't mind, trust me for a little bit, and when the next problem, which might be next time, I don't know, it will actually show us the sequence here. So what I'm going to do, I'm going to use this, and I'm just going to go in here and say, I want to take these 3 normals. Okay, let me repeat myself. It's not a normal, it isn't normal. Think of it as being a unit vector. So first, this one's pretty easy. The unit vector from D to C is pretty easy. Now, I'm using X and Y coordinates like this. So in that particular case, it's just minus I. So I'll just box it and say, I'll just use that. This one's the second most easy, well, it probably is the most easy. Unit vector from D to F is going in the minus J direction. 30. So we'll just hold on to that. This one has to be broken down. The unit vector from D to E is going to have a little component going to the right and a little component going up. So what it's going to be is cosine 30 I plus sine of 30 J. So let me focus on that one a little bit more by zooming in, and that's apparently that's as much as I can zoom in. So let's say that's unit vector. So this is of length 1. That means we want to find the component here, which just happens to be 1, the length of this vector here, times cosine 30. Oops. And then you got the component going up right here is 1, the length of this. If this were a length of 2 or 3, you'd have to put that in there, but it's the length of 1. Oops. So it is sine 30. So those are the length of the two vectors that make that up. So I'll just write those down right here. So I've got all 3 of these. And again, I'm focused on this ring itself. So if you want to, you can say, well, I want to know the tension in DE as a vector, written as a vector. Well, that's going to be the tension in DE, whatever that number is. So I'll say this is the scalar portion of that, times the direction, UDE. Okay, so I want to know the tension in this rope, which is DF. Now, you already know that numerically what it is. The tension in DF, whatever that number is, which happens to be that, but times its direction, DF. Okay, so let's just, does this making sense? So here I have a direction. I have the actual value, which I actually have it. So if I want it written as a vector, I can write it like this, and we'll write it out. I mean, if you want to, TDF. Now I'm going to save writing this completely out, but 196.2 UDF. Now, if you look at UDF, it's like TDF is equal to, you take this, it's minus 196.2 J. So it is pointing down, but we're gonna use this at first. But this 2 things I'm trying to do just to get you to see that I'm not really doing anything new. I just have a new what do you call it? Symbol right there. Okay, so I've got that one. Okay, I should box this one as well. And then I got the one up here, which is the tension in DC is equal to whatever that tension value is times the UDC. And those are the those are the only 3 forces on that funny ring right there. So all I got to do is, sum all these forces together. Well, all you get is T, DC in no particular order. So I'm going to take this one as 1, and take that one as 2, and this one as 3, plus T, DE as a vector, plus T, DF. So I wrote all 3. So what is that equal to? Well, it's supposed to be equal to 0, 0, 0. There's 3 components here. So really, technically, I should write it like this. 0I plus 0J plus 0K. It's kind of hard to figure out exactly what's the best way to write this, but I'll just say that that's what it is for the moment. Now, what I'm going to do is I'm going to take these all of these together, and I'm going to write them all the way out. And then I'm going to take those and combine them back together to show you the equation, the form of the matrix equation. And so, so let's do DC since I got it first. Okay. Whoa, that's weird. Okay, that's even weirder. Okay, so I'm going to take this term. When I take that term, I'm taking this, which is this, and I'm going to write it down right here. So what it is T DC times a minus I. I'm going to put a parentheses down there because that's the U, or maybe I should do the secondary thing. I'll do the first step and then the second. So in other words, I'll write what is in the boxes first. UDC plus the value of DE. So I'm writing this one right now. Times UDE. And then I'm writing the last one, TDF times UDF. And I guess I could write, I don't know. I'll go ahead and write these three terms, and I'll do that for a reason in a second. So now you've got these in a very strange sense. Let's focus on this one. I'm going to write it completely out with terms that don't even exist. DC times what I, what J, and what K. Well, first of all, I don't have any K here, so but I'm carrying it anyway. I'm going to carry all of it. So, carrying it all, DC. What is DC? It's just that. So it's -1 plus 0 plus 0. Big deal. So now let's do DE. Okay, what is DE? So if you look back at what DE is, it's this. Let's see if I can do this. Cosine of 30i plus sine of 30j plus 0k. And then I'm supposed to add these together, so I'm put a plus sign in front of that one. And then plus TDF of whatever that base vector there is, which that's just a minus j. 0i minus j plus 0k. Now, if I want to write this as a matrix, which I've almost done, kind of, but you have to kind of tilt your head sideways to see this. You can write all this out, and then you can do, now what I'll do is write it, and I'm going to include the ij and k. So the ij, sorry, yeah, all right, I could say x, y, z, ij, I'll say this. I don't know any better way of doing it. And then what I'm going to do is I'm going to say T, DC, T, DE, and tension in DF. And then I'm going to take the right-hand side and say 0, 0, 0. So I took the I and put right here, took this put right there. So you can see the sequence there. Now, let's look real close at how this goes together. So this one should be the first equation in the X. So in the X, you'll see this, this, and this. That's with the X. So hang on, let me switch my pens back. So what you're going to end up with is a UDC, UDE, and UDF. I'm writing this ahead of time, but the way these should be written, this should go right there. And this term should go right there. And this term should go right there. That's the easiest, so I'll write it first. Cosine 30. Oh, wait a minute. Sorry. So this is, I've goofed this up backwards. Okay, hang on. That's not where these two should go. This should go there. This one should go here. And this one should go here. Okay, I didn't finish that. Cosine 30 and then 0. What you're going to see out of this is something that you might ask yourself, why did he include the k component, especially since it's 0, 0, 0. So let's just go ahead and do the 0 first. So on that, you're going to do 0, 0, and 0. On that, this one you're going to see 0, sine of 30, and then minus 1. So when you have a minus in front of it, you got to put the minus 1 there. So the last equation is TDC times 0 plus TDE times 0 plus TDF times 0 is equal to 0. So for a 2D problem, usually you don't even list that. But I did it for this in general. And it's okay that it's there. But this is a two-dimensional problem, so you don't need that. But in the next section, you'll see that you kind of do. So you look at this thing, and if you multiply this back out, you should get the equation above. So in other words, TDC times the minus 1, that TDE times this term is, this term. And then there isn't any one there. Then TDE times sine of 30, TDE times sine of 30. And then the only other term you had is TDF times that. So you get all the terms out of here. But the structure is such that this vector listed vertically is one of the unit vectors. And this one listed vertically is the unit vector, and this one listing vertically is the unit vector. Turns out that the first one is associated with this, the second one is associated here, and the third is associated here. So you start seeing a pattern that occurs every single time. Then the question is, how do we proceed from there? Well, we knew, and we started off with this, that the TDF ends up being 196.2. So if I wanted to put it in there, whoa, hang on, I can, like right here. So I can go in here and strike that out to say 196.2. Now, if you carry that out and multiply it, what you'll get is, and I'll just simplify things, cosine 30, 0, sine of 30, and you will get 2 out of here, TDC and TDE. And then I'll go ahead and add that, which will be, let's go ahead and let's see, how do I do this? If I multiply this times this, I get that times 196.2 and 0 equals to 0, 0, 0. Then I can move it to the right-hand side and get minus 1, cosine 30, 0, sine of 30. Now the key is when you write the equation down here to sort of check yourself, you can, okay, hang on. Let me finish this up. Move it to the other side, it becomes positive. Is in fact, this is a unit vector. Okay, the first column would be D pointing to C. And is in fact this the unit vector pointing from D to E. D to C. Let's see what that is. D to C, yeah, that's that one. And then D to E is that one right here. Or plus cosine plus sine. Plus cosine plus sine. Yeah. So we've got that. So now all I got to do is solve that equation. And I can just do that inside of Octave by, oops, wrong one. Okay, wait. Okay. So we'll set up the matrix, say, K, I don't know what else to call it, minus 1 cosine degree of 30, then 0 sine degree of 30. And there's that. And then the right-hand side is just going to be equal to 0, 196.2, if I copied that down correctly. And now I can do inverse K times the right-hand side. I get, oops. Oh, it's non-conformal, so I have to get rid of the, okay. It doesn't like that. I'll show you why it doesn't like that. Okay, so because here's why. It's my fault. Here's why. This is now 2 by 2 multiplied by 2 by 1, and it cannot equal to a 3 by 1. Three rows in one. So I've got to get rid of that. So it's a 2 because there's no z component here anyway. So the z can disappear. As long as that is the y and this is the x, I'm good. So out of this, I got an answer of 339.83 and 392.40. And that should be listed as this and 2DE. Now, I'm going to do the second ring in a second. But before I do, I'm going to just check and make sure I don't think. What was this problem number? 329. Okay. Just going to do a double check. Okay. Those are not there. Okay, wait a minute. Was this a fundamental 329 or was this not a fundamental 329? No, it's just 329. There's 2, well now there's 3. Okay, what am I looking at? Okay. What's going on here? Okay, I'm very baffled. I thought, what is going on? 329, right? 329. That's it? 3, 1, and 3, 2. Is are these the fundamentals? Oh, these are preliminary. Okay. Sorry. Oh, there's another one of R. Oh my God. Okay, that's what I'm looking for. Golly. Okay, so there's your 320. Let's copy that over to the other page because I'm not going to remember it from page to page. And we'll go back over and we'll just drop it there and see. Okay. Now, first of all, he lists his as F's. I didn't. So DC. Okay, CD. So that's what he got for my. So if you round that up, it's okay. DE 392. And I guess if you round mine down, you've got that. So let's take that and just go immediately and solve the second one part of the problem. And that's associated with the second ring. So what I'm going to do is copy the whole thing, copy the picture in other words. Uh-oh, what happened? Okay. I thought I had the picture. Copy. So we're going to copy the picture, and we're just going to go straight, immediate to the matrix. Now, see, okay, hit the escape key. I don't know why it gets stuck in this mode. Okay, so there's the unit vector from C pointing to D. There's the unit vector from C pointing to B. And there's the unit vector of C pointing to A. So what I'm going to do is list those three out. The UCD, that's the easiest. It's just equal to I. It points straight to the right, not a big problem. This one, pretty easy to, probably the set, I don't know if it's the second most easy. UCD, it points back to the left, and it's 1 over square root of 2, because, remember, cosine of 45 is equal to the sine of 45 is equal 1 over square root of 2. And you got 45 here. And then it points, okay, so it points to the left, but it also points down. Minus 1 over square root of 2j. Now this one, UCA, is, and here I'll use the components. So it shoots back to the left 3/5 of I, and that means I should have had a minus 3/5 of I. Shoots up 4/5 of j. So now hang on, I'll box this. I'll box this. And I'm going to immediately take these and write the equation. So the way I'm going to do it is I only have an I or an X, and I only have a J or a Y, and I'm going to write these as, I don't know which one to write first. How about UCD? And then I'll write the vector U. I made a mistake here. That should have UDCB. That's the vector going back. So sorry about that. UCD, UCB, and UCA. So I'm going to write these vectors. And well, I'll do UCD, so I'll write that in there. That is a 1 and a 0. UCB, that's this one. Minus 1 over square root of 2. Minus 1 over square root of 2. And UCA is minus 3/5 and 4/5. Now I'm going to write the tension associated with that particular base vector, which is the tension in CD. It should be the tension in CB. And it should be the tension in CA. And, okay, so this is a 2-row, 3-column times a 3-column by 1 row. The inner dimensions must agree. And so the output should be a 0 and a 0. Sum of the forces equals 0. And so now I know one piece of information that I can pass over, and that is from the last one, and that is the tension in DC. So the tension in DC are the same thing as the tension in CD, which is that first one, which is 339.83. And I can rewrite the equation. Let's do it this way. I can rewrite the equation. Okay, So if I do a copy, and I drop it right here, I'll rewrite the equation, and I'll take that in. And so what I'll do is I'll write, wait, it was CD. I'll write that in as 339.83. So if you rewrite the equation again, you can rewrite it like so. Let's see, copy, paste it. Oh, I don't know what happened there. Okay. So, yeah. Move this up. Okay, so this is what you get. Oh, that doesn't look right. Okay, plus. Okay, that's this times that, which is 339.83. And a 0 equals to 0 and 0. Again, this is the x and this is the y. And you move that to the other side and you get a equals to minus. And now I can stick those in. See if I get the right answer out of that. Wrong thing. Let's see. I want that. Okay, but now I got to go back to here and then do it. Okay. So the k over here is going to be a little bit more difficult to put in. 1 divided by square root of 2 and then minus 3/5 minus 1 divided by square root of 2 and then 4/5, and hopefully I typed it in correct. Good grief. Why did I put in a 45? Oh, 4 divided by 5. Sorry about that. So now I've got the k. Got to get the right hand side in there correctly, and that's minus 339.83, and then a 0 underneath that, and then I do the inverse of k times the right hand side. Okay, 274, 274, okay, 0.62. And then 242.74. That's the tension in CB. It's the tension in CO. Now, I don't know if I got that right, but oh, so yeah. Oh, I copied that. I didn't. Okay, hang on. Okay, here. Okay, so we can zoom in right here and check it out. So again, he used CF, and I used the tension. I guess if you round that, you'll get this one. CB. Okay, so it's FCB for him. It's tension C. So I guess if I round mine up, I get that. And so essentially that's it. So these problems always flush out that way. It's very strange, but yet if you do them a couple of times, you realize they always flush out as matrices like that. We can go back to the book for a second. Maybe we'll do that. And okay, where is it? Okay, so if I go back up, let me just go into the book in the 2D, and we might be able to see the structure in there in one of the problems he works. Okay, maybe not in that one. Well, he doesn't. It's really not. I guess. Okay, so if you look at it real close here, well, is there a better one? This might be the better one. Okay, so let's look at this problem. If you look at it, okay, so the structure does show up here. And let me kind of play with this for a minute. So let's look at the TC, this one. And let's look at the structure that shows up. So if you look at this, there's your TC. Okay. Then if you look at this B, the tension in the A cable, you see that kind of shows up. Now think about this for a minute. This is the Y, the bottom one's the Y. The top one is the X. So if you look at this, let's just take TA right up here. And you took a unit vector going this way, you're going to have a negative going in the X. Notice the negative, and it's going to be 4/5. And you're going to have a positive in the Y off of this cable right here. So you can see how you end up with a minus, and you can see how you end up with a positive. Now, this term only shows up here because it's going down. And so currently it's over here. Then they'll move it to the other side. Hopefully they do. And so basically he says substituting into the equation 2. So he's doing this substitution, but you can start to see how the matrix is being formed right here. So there is a matrix equation right here. Now, granted, there are times that it's easier to solve it without, but if you start seeing the structure always develop in that, hang on, in that I got a TC and then a TA, and you start looking at it, you see cosine of 45, and you see sine of 45, and then you see this minus 4/5 and 3/5. Suddenly you see the unit vector C and the unit vector A. And so just looking at those terms, you start seeing that. Now, when it comes to 3 dimensions, it becomes even more apparent that maybe that's something to do. And let me see if I can jump to that problem, and then the problem he has in the book. And we'll come in next time and work some of the 3D. So there's this 3D equation. He has an extra term, sum of the forces in the Z. Go down here. I don't think it's as apparent on this one as, okay, so if you start taking a look at real close what he does. First thing he's doing, he is finding the unit vector. And he has the unit vector. And guess what he does next? He finds the unit vector along C. So he has the unit vector there. And then he has D, which actually D, pretty simple. It runs out that way. So suddenly, if you look at this thing, he shows you this. And maybe we'll use this as a model, because if you stare at this long enough, and he didn't line it up as the way I would have liked to see it lined up, but I don't really know what else to do. But if maybe we'll work this problem our way, and we'll compare it to this next term, and we'll see that this in fact is a ridiculously written out version of the matrix. And actually, I have to eat my words, because if you look right here, that's what you're seeing. That's the matrix equation. So this is okay, so I eat my words because he expands that back out right there. So there's the actual matrix equation. He has his 40. He needs to move his 40 over. But these other terms are sitting right there. If you look at FB, there is take a real close look at that and compare that to this. And you'll see the minus 318, the minus 42, and then 84. You look at this, and that is going to be the unit vector there, the minus 318. Oh, wait. Did I already say that? Yeah. Minus 318. Maybe I said that already. And then the 424. 424. And the 8-4. It kind of confused me there for a minute because there's an 8-4-8 on both those and a 4-2. He's basically split these in a strange way. So I think I may call it quits right now. So I may need to go to the take a break between the two classes here for a second. So there you go. It is what it is. So we'll come back in.